Okay, today I'm going to be going over balancing equations. I'm going to go over our notes real quick and then two examples. So starting off with chemical formulas. For a chemical formula, you need to have a compound. And a compound is made up of two or more elements. For example, we have carbon dioxide, which is made up of carbon and oxygen, so two different elements. Next, we have the law of conservation of mass. And it states that during a chemical reaction, matter is not created nor destroyed. That means that the number of atoms of each element on the reactant side has to be equal to the number of atoms of each element on the product side. Coefficients. A number placed in front of a chemical symbol or formula. This number can be changed. For example, for CO2, 4 is a coefficient, and I could always change that 4 to a different number. So I could make it 3, I could make it 2, kind of depends on the whole reaction. Now to figure out how many C's or carbons we have and how many oxygens we have or O's, we have to look at the whole compound, including the coefficient. So if you look at 4CO2, how many C atoms are there in 4CO2? To figure this out, we distribute the 4. So since there's no number after the C, we know that there are 4 carbons. To figure out how many oxygens there are, we have to look at the subscript after O, so in this case it's 2, and we're going to multiply it times the coefficient, so 2 times 4, which is how we get 8 oxygen atoms. Subscripts. You guys already know a lot about subscripts. The subscripts of a formula tells you the number of that element in the compound. Subscripts cannot be changed. So unlike coefficients, subscripts cannot be changed. For example, C6H12O6, the subscripts cannot be changed. So carbon is only going to have 6 atoms, hydrogen is going to have 12, and oxygen is going to have 6. Now I could put a coefficient in front of carbon. Okay, so let's do some practice, and I'm going to change screens real quick. Alright, so here's our first example. As you can see on the left side of the screen, we have our reactants. Then we have our arrow, which remember means yield. And on the right, we have our products. Okay, and what we're going to do is try to balance this equation. So the first step that you want to do, and I've already gone ahead and done this, is you kind of want to draw a straight line underneath the arrow to separate the reactant side from the product side. The second thing you want to do is to list all of the atoms or elements that we have. So we have hydrogen and oxygen on both sides. The next thing that you want to do is count the number of each that you have. So if we look at the reactant side, I see that I have 2 hydrogens, as noted by my subscript. So I'm going to go ahead and write in 2 next to my hydrogen. Okay, then I'm going to count my oxygens. Once again, I have a subscript of 2, so I have 2 oxygens on my reactant side. Now on my product side, I have a 2 subscript after H. But for my O side, for my O on the product side, I don't have any subscripts, so it's just going to be 1. So whenever you see an element without a subscript, you're just going to write 1. Now if you compare the left side, so my reactants, to my products on the right side, you see that the hydrogens match up. However, my oxygens don't match up. So what I need to do is add coefficients to make my numbers have the same on both sides. So the first thing I want to do is look at something that isn't equal. So my oxygens in this case are the best place to start. Now since I need 2 oxygens for this to match, what I'm going to do right here is add a 2 coefficient. And when I do this, I need to recount my atoms. So now that I've added this 2 coefficient, I'm going to cross out this 2. And what I'm going to have to do is figure out how many atoms of hydrogen I have. So once again, I'm going to take my subscript 2, and I'm going to multiply it times my coefficient 2. So 2 times 2 equals 4. So I have 4 hydrogens on my product side. Next, I'm going to look at my oxygen. It has an invisible 1 there, so 1 times my coefficient, 2. So my new number over here is going to be 2. Now if we compare both sides, my oxygens now match up, but my hydrogens don't. And I have more hydrogens on the product side than the reactant side. So what I need to do is put something in front of my hydrogens over here on the reactant side to make it equal to 4. So if I put 2 over here, what's going to happen is I'm going to multiply my coefficient 2 times my subscript 2. So my subscript is this little one here, and my coefficient is the red one. So 2 times 2, and that's going to give me a new amount of hydrogens, which is 4. Now when I compare both my reactant side with my product side, I now see that my numbers match up. So for hydrogen, I have 4 on both sides, and for oxygen, I have 2 on both sides. So I know I'm done. And this equation is complete, and I followed the law of conservation. The amount of atoms going in is the same as coming out. Let's try one that's a little bit harder. Okay, so once again, I've already gone ahead and set it up. So I drew my straight line, separating my reactants from my products. Next, I've listed all my atoms on both sides. So I have C, O, and H. Now the next thing I'm going to do is I'm going to count my atoms. So on this side, I have 1 carbon, and I have 2 oxygens, but I also have an oxygen over here, so I need to add it all up. So 2 plus 1 is going to give me a number 3. Okay, and then for hydrogens, I have 2 over here. Alright, now on my product side, once again, I'm going to count everything up. So for carbon, I have 6. For hydrogen, I have 12. And then oxygen is going to be tricky again. I'm going to have to add up both. So I have 6 over here, 2 over here, so that's going to give me a total of 8. Now when you're trying to balance the equation and you see that none of these are actually matching up, it's always easier to start with the biggest difference. So if you look at the hydrogens, one is 12, the other is 2, and that's a really big difference. So it'd be best to start here. So what can I put in front of this H2O to increase my number of hydrogens to make it 12? You're right, I'm going to put 6 there. Now when I add the 6, I need to recount all my atoms on this side. So I have now 6 times 2, so I'm going to have 12 hydrogens. And unfortunately, this has also changed my number of oxygens. So now that I multiply this out, I'm going to have 6 oxygens, but I also have to add the 2 over here. So now I'm going to have 8 oxygens on my reactant side, which actually really works out nicely if you look at my product side, which also has 8 oxygens. Okay, so now I need to figure out a way to match up my carbons. So over here I have 6, so I have a lot more. So I'm not going to change anything on the product side, but what I am going to change is on the reactant side. So what can I put in front of this carbon, or this CO2, to increase my number of carbon atoms to 6? You're right, I'm going to put a 6 here. So when I do that, I need to change my numbers. So now I'm going to have 6 carbons. Oh, but something has changed. Now my oxygen is going to be thrown off, because now instead of having 8 oxygens, I'm going to have 6 times 2, which is 12. And I'm going to have to add that with the other oxygens I have over here. So 6 times my invisible 1 subscript. So I now have 18 oxygens on my reactant side. Now my hydrogens luckily weren't changed over here, so I don't have to do anything with this. However, I do need to make sure that I have equal amounts on both sides. So my hydrogens match, my carbons match, but my oxygens don't match. So now on the product side, I have to change one of these to make sure that I get the same amount of oxygens. Now I could put a number over here, but that's also going to affect my carbon and my hydrogen. So it's probably not best for me to add a subscript. Probably not best for me to add a coefficient. Instead, I'm going to add one over here. What number could I put over here to increase my total from 8 to 18? You're right, I'm going to put a 6 here. And when I put a 6 and I multiply it out, it's going to be 6 times 2, which is 12. And then when I add the other oxygens from my C6H12O6, add 6 more oxygens, and now I have a total of 18. So for one last check, I'm going to compare all my atoms on both sides. So I have 6 carbons, 6 carbons, 18 oxygens, 18 oxygens, 12 hydrogens, 12 hydrogens. So now I know that my equation is balanced. Sometimes we'll go ahead and just put a 1 wherever we see a blank, and that's good practice for you to do. So whenever you see a blank that we don't need to balance anything, just put a 1 there. It's kind of an understood value. And that sums up how to do balancing equations.